In level 2, we will be solving polynomial inequalities, and all of the inequalities, or the polynomials, will be quadratic functions. And once we get to level 3, we'll have higher degree functions. So we'll start with the steps. The first step is to get 0 on one side. The second step is to get your polynomial in factored form. The third step is going to be to find the zeros of the polynomials. The fourth step is going to be to place the zeros on a number line. And you want to make sure they're in order. And you're going to test regions, and I'll show you what that means in a minute. And then your final step will be to write your answer in interval notation. Okay, so if we look at this first example, steps 1 and 2 are actually already done. We already have 0 on one side, and the polynomial is already in factored form. So we're going to jump down to step 3 and find the zeros. The zeros of this polynomial are -3 and +2. And I'm going to put those numbers on a number line. And now I'm going to test regions. And to test regions, we're going to pick a number in each region of our number line up above. So I'm going to pick a number that's less than -3 in this region over here. So any number less than -3 will do. I might use -4. To test x equals -4, you're going to plug -4 into factored form above. So I'm going to plug -4 into the first factor, and -4 plus 3, all I care about is if it's positive or negative. If I do -4 plus 3, I'm going to get a negative. And then I'm going to plug -4 into the other factor. -4 minus 2 is also negative. And when I multiply a negative times a negative, I always get a positive. So in this region to the left of -3, I will have positive y values, or positive values for the function. That means the graph is up above the x-axis on that interval from -infinity to -3. Okay, so now I test my next region, and I'm going to pick a number in between -3 and 2. So I might use, an easy number to pick would be 0. So I'm going to test x equals 0. And so I plug 0 into factored form up above again, and 0 plus 3 comes out to be positive. 0 minus 2 comes out to be negative. And if I multiply a positive times a negative, I always get a negative. So in the middle here, we have negative y values, or the graph is down below the x-axis over that interval from -3 to 2. And now I'm going to test my last region, which is for x values greater than 2. So I'm going to test any number that's bigger than 2. I'm going to use 3. And when I plug 3 into x plus 3, I get a positive. And when I plug 3 into x minus 2, I also get a positive. And a positive times a positive is always a positive. So it's positive in that region, meaning the graph is back up above the x-axis when x is greater than 2. Okay, so then now I'm ready to write my answer in interval notation. And I have to look at the inequality back from the beginning. The inequality is a less than symbol. That means I want to know when this polynomial is less than 0 or when it has negative y values, and that's when the graph is below the x-axis. And the region on the number line, where I just tested the regions, I'm going to choose the region where I got a negative y value, because that's where in between -3 and 2 is going to have all negative y values, or that's where the graph is less than 0. So I need to write -3 to 2 in interval notation. Since our inequality was less than, not less than or equal, I'm going to use parentheses because the graph actually equals 0 at -3 and 2. So it's -3 comma 2 with parentheses. And that's my answer in interval notation. In the next example, I do not have 0 on one side, so I need to move the 15 over to the left side, and I'll get 2x squared plus x minus 15 is greater than or equal to 0. And it's not in factored form, so I need to factor this expression, and we get 2x here, an x here, and I need two numbers that multiply to 15. I'm going to use 3 and 5 with a 5 here and a 3 here, and this should be negative and positive. So now we have it in factored form, and we want to find the zeros. So to figure out what makes 2x minus 5 equals 0, I make a little equation, add 5 to both sides, and we get 2x equals 5. Divide both sides by 2, x equals 5 over 2. So my zeros are going to be 5 over 2 and -3. So I put them on a number line. Make sure they're in order, so -3 needs to be on the left, then 5 over 2. And now we're ready to test regions. So I test a number to the left of -3, like -4. And when I plug -4 into 2x minus 5, I get a negative. And when I plug -4 into x plus 3, I get a negative. And a negative times a negative is always positive. So we get positive in this region. And then when I test something between -3 and 5 over 2, I'm going to test 0. And plugging 0 into 2x minus 5, I get a negative. Plugging 0 into x plus 3, I get a positive. And a negative times a positive is always negative. And then I would test something greater than 5 over 2, like 3. And when I plug in 3 to 2x minus 5, I get a positive, and when I plug in 3 to x plus 3, I get a positive, and a positive times a positive is always positive, so it's positive in this region. And now I'm ready to write my answer in interval notation. So this time my symbol is greater than or equal to. So I want to know this time where the graph is up above the x-axis, or where it has positive y values. So I'm going to choose the two intervals where I got pluses. So the interval on the left side I would write as -infinity to -3, and since my inequality has the or equals line underneath, it actually equals 0 at -3, and I include that point by using a bracket. And then I do union, and my other interval is from 5 over 2, again a bracket, to infinity. Then we have one last example. This one is, we do have 0 on one side, but it's not in factored form. So to get this in factored form, first I need to multiply out my x minus 1 squared, and that's x squared minus 2x plus 1 minus 49. I combine like terms and get x squared minus 2x minus 48 is greater than 0, and then I put this in factored form, and we get x minus 8, x plus 6. And then I find the zeros, which are going to be positive 8 and negative 6. I put them on the number line with negative 6 on the left and then 8, and then I'm ready to test my regions. So I'm going to test a number to the left of negative 6. I'm going to test negative 7. And when I plug negative 7 into factored form, negative 7 minus 8 is negative. Negative 7 plus 6 is negative, and a negative times a negative is a positive. Next, I'm going to test something between negative 6 and positive 8. 0 is an easy one. So if I plug 0 into x minus 8, I get a negative. 0 into x plus 6 is positive. Negative times positive is negative. And so we get negative in that middle region. And then next I'm going to test a number greater than 8, like 9. And when I plug 9 into x minus 8, I get a positive, and 9 plugged into x plus 6 is also positive. Positive times positive is positive. So we get positive in that region. Okay, and then now I'm ready to write my answer in interval notation. This time I have a greater than symbol, so I want the intervals where the graph is up above the x-axis, or where it has positive y values, and those are going to be the intervals where I have my plus signs. So on the left we're going to have negative infinity to negative 6, and since we don't have the or equals line under the inequality, I use a parenthesis around negative 6 because it actually equals 0 at negative 6. It's not greater. And then we do union, parenthesis, 8 to infinity.